Okay, we are in vertex form by completing the square. So yesterday you learned about completing the square by saying this constant isn't any good to us, move it over and create a different form. Well, completing the square not only helps us when we're solving, but this method helps us to transform our equations. Think about when you were in Algebra 1 and you had an equation in standard form. It wasn't the best form for you to use when graphing, unless you were using x or y intercepts. So you changed your equation by rearranging it into slope-intercept form, and it was a lot easier for you to graph. The same is going to be true for a quadratic. Standard form of a quadratic is an ax squared plus bx plus c. Here we said, what's the vertex? Well, the vertex, if you recall, is the opposite of b over 2a, and then you substitute that back in. Everything I'm saying right now can be shown in a PowerPoint, which you're going to refer to. It's in your classwork, okay? When you do this, you're going to see that opposite of b, 2, over 2a, which is 2, which is 1, so your x value is 1. When I put 1 into my function, what do I get? I get 1 minus 2, negative 1 plus 3 is 2. So my vertex is 1, 2. So if I were to graph this quadratic, 1, 2 would be at the bottom of the parabola. Okay? We can't see 1, 2 in here. This is in standard form. Can we see the translation or transformation from x squared to negative 2x plus 3? Did it go left? Did it go right? Did it go up? Did it go down? We can't tell. It said there's an easy way to answer these questions instead of doing opposite of b over 2a and just kind of graphing. We just have to rearrange the equation into vertex form. If you want to use the PowerPoint, it's a lot cleaner, the work, and you can see the steps easier, or you can just watch this video. So here we know that 3 is not beneficial to us. However, we can't put 3 on the other side because we're changing the form. So all we say to number 3 is, hey, move over for a minute. We can't use you right here, but we can put you over here. Now, your b is 2. We said take your b, divide it by 2, and square it. So it's going to be 2, negative 2 over 2 squared. Doesn't matter if you put the negative or positive because it's going to get squared. And you end up with a 1. So I'm going to add a 1 in here. And why do I want to do that? So that I get x minus 1, x minus 1. But wait, if I add 1 to this side, I have to add 1 to this side. But I can't just add 1 here, so let's move it over here and it will become a negative 1. So this is the new concept, keeping everything on the same side. Well, why can I just do that? Because it's where I put the numbers. Some people are like, why would you add 1 if you're just subtracting 1? Because if I'm going to put that negative 1 by the 3 to make it a 2, and I'm going to put this positive 1 with these so that I can change the form. So I'm giving this equation a makeover. All I'm doing is saying, hey, this equation and this equation are the same thing, except for this is in standard form and this is in vertex form. Because vertex form is y equals a x minus h squared plus k, where hk is the vertex. Okay, hk is the vertex. So look, 1, 2 is the vertex. Yeah. Well, why does it say minus h? Because when we move from left to right, to find distance, we use subtraction, right? So that's why it's negative. So don't look at this and think left. It's thinking the distance created. So h is actually positive. Now, if h was negative, it'd be negative, negative to create a positive. All right, so that's actually to the right one because it's actually a positive 1. So this form is very beneficial for us. We can see all the transformations and we can see the vertex. Okay. A is going to be the vertical stretch or shrink. If it's 1, there's not going to be either. Okay. Now, to get the hang of that, because you're like, whoa, that was a lot that you just said, all I want to do is, what is the vertex of all the following equations? So I want you to pause and try to write them all down and see what you get. Okay, it's actually a positive 3 and a 1, a 2 and a 3, a 5 and a 0, because there's nothing there. If it's positive, that means it was negative, negative. So it's a negative 2, 1, a negative 4, negative 5, and a negative 1, 0. Okay, put stars or circle anything that doesn't make sense and you need to talk about. All right, here it says, rewrite each equation in vertex form by completing the square. Find the vertex, axis of symmetry, and translation from the parent function. So part A, you're going to tell that 20 to scoochy, scoochy. You're not helping me. You need to put a new constant in there that's going to help you. Oh, I'm so sorry. This document is awful sometimes. So B is 12 divided by 2 is 6. And then square it, you're going to put a 36 in here. So B divided by 2 squared. So your B was 12. You're dividing it by 2. And you're squaring it, so it's 6 squared. If I add a 36, I must subtract 36 to keep my equation balanced. And it's okay because it's where I put the number. Okay, so my equation is now in vertex form. So it's going to be negative 6, negative 16 is the vertex. And so the axis of symmetry. So if I were to graph this, this line straight up and down is x equals negative 6. Okay. And it asks for the translation or transformation. So I went down 16, doesn't matter the order. And I actually went to the left 6 because it's actually negative 6. Okay, if that was too fast, go back. All right, here you tell that 15 again that it's not beneficial. Remember, we have to factor out the 2. That 15 isn't a part of it. Two divided by 2 and squared is 1 squared, which is 1. So I'm going to add a 1 in here. But am I really adding a 1? No, I'm really adding a 2, so I better subtract 2. So y equals 2, x plus 1, x plus 1, minus 17. Y equals 2, x plus 1 squared, minus 17. Okay, so the vertex is negative 1, negative 17. There's a vertical stretch of 2. And then there is a left one. And then a down 17. Okay. All right, that's it. The bottom is just having you graph it. It says when a quadratic equation is written in vertex form, it's easy to sketch. You find the vertex and then you find 2 points around it. So here your vertex would be negative 1, negative 9, and then you'd pick other points. You would pick a negative 2 and a negative 3, and then 0 and 1. Whatever it is for 0 is going to be the same thing for negative 2. And you've done this before. Here, though, they're saying you could have done negative 1, negative 9 from the vertex and then pick zeros or solutions. So you could have brought 9 to the other side, take the square root of both sides, add 1 to the other side, gotten x equals 4, x equals negative 2. And just graphed it that way. So you could graph using intercepts in a vertex, or you could graph using 5 points total. Okay, it's totally up to you. You're going to get the same graph. So it's just another way to help you graph. Your homework is going to be this worksheet in your notes. It's vertex form of parabolas. I want you to do the same methods and then write also transformations. Now, I think homework some people are getting overwhelmed or stressed with. You do not have to do all of these, okay? But I want you to have that option. So at least if you're having a hard time with homework, say, I'm going to do at least 3. Pick one easy one. Pick one in the middle. It's probably harder. And don't worry about the back. I don't want you doing the back. Just do the front. Okay, pick a few out of here. And then you'll see how much you need to do. Just choose at least 3. Come in the next day and on the chalkboard, write the ones you want to go over, and I'll go over them. Like I said, I don't know you need help unless you ask me or tell me. Okay, so make sure you're telling me if you do. That's your homework. Like I said, I don't grade your homework. I grade your homework quiz. So I give you a quiz on a few problems from each night's assignment, but you can use your homework on it. It's there to assist you, so you don't have to go back and try to do all of it. Some of you aren't doing any of the homework, and then you're just trying to wing the quiz. Don't do that. Have your resources with you, okay? And the next video is going to be on the quadratic formula.